Hello, good evening. Hello, can you all hear me?
Good evening, ma'am. Yes, we can hear you.
Hi, good evening. Okay, I think we'll be waiting. That's what Sir said for 2 more minutes and then we will start off. Thank you so much for joining in today. All right, I think we'll not waste much time. I would like to know where are you all joining from? Hello, I hope I am audible. Am I audible or no, guys? Teachers?
Yes, ma'am.
Ma'am, you are audible.
Okay. Could you all help me to understand where you all are joining from? Sorry, I cannot see the chat. Can you all see my screen?
Yes, ma'am.
Okay. And please let me know if you can see something else on my screen. Can you still see my screen?
Yes, ma'am.
Okay. All right. So let me introduce myself. I'm Vichitra, and I'm a veteran IB educator. So it's been 10 years in IB education. I'm sure you all must be knowing what an IB is. IB is International Baccalaureate Program, and we have many schools in India offering international curriculum. So I'm the MYP, which is Middle Years Program, and DP, Diploma Program, which is 11th and 12th. Um, Great teaching biology there. And I have had an experience of teaching various curricula. I've taught in the state board for over quite some years and a decade in CBSE curriculum, and now over a decade in IB curriculum. So I'm very, very happy and delighted to be taking this session here, and I hope you guys, I know that y'all are quite experienced, and please forgive me if something goes, haywire, or I just go astray my talk from the PPT, because I have some experiences which I would like to, my classroom experiences, which I would like to bring in here. So thank you so much for joining in today. And we can make it a little interactive by, keeping your, unmuting yourself, talking out, asking questions wherever needed. So I think we can begin. And as you all have seen in the flyer, um, the topic for today is inquiry based questions, inquiry based learning, and inquiry based teaching. So, I would like to start this way. When we all were students, what was the most exciting science moment you all had as students? If you could just unmute and speak. Hello.
Hello, ma'am. Good evening.
Hi, good evening, Manisha.
I think we all can remember from our, school days, the very early experiments that we see in our classrooms, which is of volcano experiment, and which is often shown even today by us in our schools where we teach. So I think that is one of those, very fascinating thing that we see in our classrooms, and that start the, um, attraction towards the subject science. And I think it's one of it.
Absolutely, absolutely. Thank you for sharing that, Manisha. Anyone else? What's that something that you remember about your science classes when you were a student? Nobody? Teachers, can we make a little more interactive? Whatever you remember. All right. Okay. So here in this session, we are actually going to see how, and we're going to see and how, we'll explore how to bring that excitement. Manisha ma'am has shared that she remembers the volcano experiment, what the teacher has done in the classroom. And I'm very sure we all have such instances in our classroom, which our teachers have taken us to the lab. Probably they have taken us, onto a field, or, in the lawn area of our school, or in the backyard of our school. And you must have somewhere wondered, why this is happening like this. Or chemistry lab, my God, those precipitation process and color changing processes, all these are nothing but they brought us, they actually provoked our curiosity, and they brought that excitement in us to learn more and to find out more. So Today's learning objectives for this session would be: one, to understand what scientific inquiry is and is not. Then, two, be able to implement a 5-step inquiry process in classroom. So here I'm going to touch upon how you can take the scientific inquiry to your classroom and actually practically do it. And it's an easy way to do it. It's not, you may think that it's going to be very tedious, but it's not. We can easily do this and make, students learning quite engaging and quite impactful. Then three, I'll share a few tools with you, a few techniques with you to make this inquiry a student-led inquiry, and how you can align them with the standards, the NGSS standards, which we in international curriculum actually use, and our national curriculum standards. Then the fourth one is we can reflect on how to make science meaningful. Here I'm going to share a caselet with you, and you can actually design a full 5-step inquiry along with me. So let's now dive into the session. So here are two classroom scenarios, or two scenarios, I would say, class A, class B. And the water lab is something which the class is about to study or ponder. So look at A, scenario A, or class A. Boil water, record temperature every minute. At what temperature does water boil? As a writer, you need to appear well-informed and trustworthy, establishing a sense of authority here and expertise your topic. So I'm just going to stop here till boil. So scenario A says, boil water, record temperature every minute. At what temperature does water boil? And in scenario B, in the mountains, water boils. Here the teacher is putting up a different scenario. In the mountains, water boils faster but at a low temperature. Now the students are asked, why does this happen? Design an experiment to find out. What difference do you see in both the scenarios? Could someone bring in the difference here? Hello?
Ma'am, I think in both the cases, the first one is, of course, both are practical application where a child would be doing it uh, himself or herself, and then would be giving the answer. But again, the first one is a pretty direct, where the child might know it from before. But in the second case, it makes the inquiry more prominent, makes the child think more rather than giving out the answer at the same moment. So I think the second situation is what makes a child inquire, think, and experiment more related to the water topic.
Thank you, Manisha. That was really helpful for me to move forward. So in which of the scenarios do you think students were able to think more? A or B? As Manisha said, it was more in B, right? Which of these two classes you felt that the students were engaging more? Because there was a real context of taking them to the mountains and giving them an example of a real context as mountains. So it added value to what they were learning. They could understand that, all right, we can apply this here. That's why we are learning, making it meaningful for them. Therefore, the students were able to connect easily. Let me take you to the second. Yes, the shadow challenge. Now, here are again two scenarios. Scenario A says that the sun causes shadows. They change direction and length based on time of a day. The teacher is explaining. Second scenario says students go outside at different times to trace their shadows and collect some data. Then they ask, why is the shadow longer in the morning than at noon? What's the role of the sun's angle? So, which approach here do you think helps students to discover the concept instead of just receiving the concept? Yeah,
It's again B.
yes, it's again B. Which one requires students to build their own understanding?
Absolutely, absolutely. So I think the situation B makes, gets them involved more, makes the classroom more engaging, and makes them more connected to the concept that we are teaching them.
Absolutely, yes. How would you assess students differently in these two settings? Could you help me with this?
Ma'am, B is experiential learning.
Right. Yes. Experiential learning. More than it, it's an inquiry-based learning. So here the students are actually going, and collecting data hands-on. So they are actually checking how the shadows are changing as per the length of the duration of the time, the day, and the sizes of the shadows, and they're trying to bring in the connection between those two. So therefore the both the settings, of course, this scenario A is a traditional way of doing it, and still we can see teachers doing this in various scenarios. But if Manisha can remember that experiment what her teacher has done when she was a student, I'm sure if you want to make you know a meaningful lesson for your students, especially in subjects like science, then I'm sure you will take up scenarios like scenario B and create scenarios B, B scenarios, more inquiry based, and make it more engaging for them, right? So we'll move ahead. What is inquiry? What comes to your mind when this word inquiry is spoken about? What comes to your mind?
Asking questions.
Asking questions. Absolutely. Wonderful. Anything else? Just give me a few words that we can connect with this word inquiry.
Like making quiz also, ma'am.
Making quiz.
Yes.
Okay. Can you just elaborate on this? Making quiz?
Like ma'am, like just ma'am said na, asking questions also. So we can make a quiz also, na?
Okay, you can make a quiz. All right.
Yeah,
So
I can.
inquiry means you want to ask some questions using
Yeah.
a tool or using a diagnostic tool, which is a
Yes, ma'am.
quiz. All right.
Ma'am, clearing doubts.
Clearing doubts. Okay. Inquiry means clearing their doubts. Okay.
Excuse me, ma'am. Inquiry means that they want to know more. Why are we taking this topic? Maybe that why are we learning this? What is the objective behind it? That is the first inquiry that the child would have. What are we going to gain from this?
Yes. Can you relate to word curiosity when we say inquiry?
Yes, the curiosity is basically that you may or may not be aware of the topic in total, or maybe the topic is totally new. So you are curious to know about it, and or maybe if you have some idea, then you want to learn more. And if I am there, I would like to relate it to my, my life experience, day-to-day life as a student. So that is curiosity. What is it basically? Why this is something new? I want to learn more about it.
Wonderful. Wonderful.
It
So,
also pushes a child towards researching and experimenting. The inquiry pushes the child for it.
Yes, yes. So inquiry is actually not something that you go to the class, do it today, and you have achieved it. So it's not that. It's a process. So inquiry is a process. Process of what? Process of, like Manisha rightly said, process of asking questions. So when you want to create, a lesson which is inquiry-based lesson, we have heard there are a lot of videos and lot of PDs available on this. But if you, look at teachers what they are doing in different places in their classrooms, so it's all about asking questions, developing that skill in students where they can actually ask questions. Tell me on this earth who is not curious? Everybody on this earth wants to and are interested in knowing things. Even if you see, um, you know, um, you see these old ladies, they all sit and they talk about, I mean, they have world's time to talk about everything, right? So you see, ये बोलते हैं ना कि गांव के बाहर आप देखते हो सब लोग जमा हो जाते हैं and then they talk. Look at our house. Who is not curious? Mother-in-law is always curious to know what a daughter-in-law is doing. Am I right? Yeah. So this is what it is. Everybody on this earth, look at a child, curious to, ask questions, curious to dig into, what is this? Why is this like this? Anybody on this earth, be it a 5-year-old child or be it a 60-year-old person. Everybody on this earth is curious to know things, curious about things. And if you feel that there are people who are not very curious, you can bring about that curiosity. You can make them, inquisitive about few things. So this is how you can develop. There are many models that have been, many theories that have come up, like Bloom's taxonomy, right from understanding level to a creativity level, how step by step, a student is led into, and inquiry based teaching is actually going to help us to achieve those levels, bring the student from an understanding level to a creativity level. Then it's a process. Inquiry is nothing but it's a process of developing models. It's a process of carrying out investigations, and it's a process of helping, when they carry out investigations. I'm sure you must be knowing investigations. So this is what I always tell, in a when I was in a national curriculum and I was doing these um, uh, experiments, right, in the lab. So aim is given to them. You directly tell them that this is the aim. I'm sure most of you are here, the science teachers, and they will actually connect with what I'm talking. So aim is given, and then the procedure is kept there, or the teacher does the procedure. Students hardly get some, experience to conduct the experiments on their own. And you have, after the procedure is done, students are made to observe what they have seen and write down what they have seen and finally conclude. And usually when I studied conclusion, we used to write, our teachers used to say, just take the aim and write what you have, add 2 words as an answer. So that is what is believed to be the conclusion, right? But here we are talking about investigation. And how can you convert an experiment to an investigation? It's very simple. I'll give you an example. You have as a biology teacher, for example, I want to know that we all know that money plant, okay, is when you pot it in a pot and you water it, okay, it grows fine, giving all the conditions required for a plant to grow, like air, the oxygen in the air has to be sufficient, and water, soil, and bright light and good humidity, and so on and so on, right? These are all the factors that will be provided to a particular plant in order to grow well. And children are observing at home also. They have their gardens, they have their mini gardens, and they are observing all this, what is happening. Sometimes they see the plant has wilted, sometimes they see the plant is dead, it's not growing anymore. Sometimes they see the leaves have turned yellow, and so on and so forth. Now, these are the questions. Students come up to a teacher and ask, why did my money plant had leaves which were turning yellow? Why is my money plant not growing, and it's been a month I have planted it? So such questions can crop up because they were curious to know about what is happening with their plant. And it's only the first skill that is developed in a student is observation. If a student is observant, then comes the investigation. So then comes the curiosity to know more about it, right? So observing skill is a science skill, is a subject specific skill which we have to, ask to develop in students. So it's a process. Inquiry is a process of asking questions, developing some models, conducting investigations. How do I convert now this money plant experiment to investigation? For example, I consider one factor, which is water here. So I'm giving water to my plant, money plant, which was I took 2 centimeter, small sapling and have put it, put it in the pot, and I'm observing it now for a month, and my plant is, has grown how much? Maybe 2 centimeter, 3 centimeter long. So experiment was pouring the water, observing it. How can I convert it into an investigation? Just change the factor, change the variable. Okay, a factor is a variable. I'll take one factor to give you all an example, and the factor is, say, water. So I'm pouring 10 ml of water to my money plant. Now I will see taking 20 ml of water, taking 30 ml of water, changing 40 ml of water to the same kind of plant grown in different pots, and I'll check which one is growing fine and which one is not growing. Then I can study and say that, okay, this is particular factor which is actually affecting the growth of this particular plant. Are you getting me, or am I quick or difficult to understand what I'm talking? I'm just giving you an example how to convert scientific experiment into an investigation. Am I clear? Am I making some sense to what I'm talking?
Yes, ma'am.
All right, thank you. So while you're doing this particular investigation, students will collect data on a daily basis, on a weekly basis, not daily, of course, weekly basis. They'll check, they'll start measuring how much my plant has grown. They'll then keep a check. They'll record all the observations and they'll record the data, 1 centimeter. Okay, in a week's time, 2 centimeters. In a 10 ml plant, it grew 1 centimeters weekly. And in a 20 ml plant, it is. So you're getting me? We've changed the factor. Variations are seen in the factor, and we are collecting the data. So it's a process of giving them the exposure to analyze the data, collect the data and analyze the data. And finally, we are in an inquiry-based classroom. We are giving them opportunity to construct evidence-based judgments. So they have the data. Based on that collected data, which was a hands-on, which was a first-hand data collection, data they have, and they have to analyze it and they'll speak why. So with that evidence, they'll be able to give authentic arguments and they'll be able to give us an authentic conclusion. So this is inquiry. It's a process. Remember, it cannot be done in one go. It's a process. It's a process of asking questions. It's a process of developing the models. It's a process of carrying out investigations. It's a process of analyzing the data. And it's a process of collecting evidences and arguing, creating their arguments based on this evidence. Now, what is not an inquiry then? As I mentioned, that in the labs, we are giving them the recipe and telling them to conduct, not even conduct. Okay, so the teacher is conducting, the teacher is giving them the question, the teacher is giving them the problem, the teacher is giving them the procedure, and the teacher is showing the solution. This is what it is, and you write it, right? This is what is happening in most of the classrooms, irrespective of the curriculum. Please don't take me wrong, since I'm in IB education, I'm saying IB class mein aise nahi hota hai, everywhere. And this comes, that's why today I wanted to, bring in this topic, because I want to equip all the science teachers, want to just motivate the science teachers to go back to their classrooms, take these learnings into the classroom and reimagine, rethink or revisit your plans and make it possible and make it happen in your classrooms. So moving from experiment to an investigation mode will definitely create a spark in your students' learning. So it's not a recipe style experiment. Inquiry is not memorizing definitions. They will come up with their own definitions. Inquiry is not guessing the right answer. They will have evidences with them. Inquiry is merely not following the instructions in a lab, but creating their own investigations and conducting it. I hope we are clear till here. Do you have any questions or anything to say till here? We have another 20 minutes to go. Is this clear? Yes, thumbs up, or WhatsApp chat, or the chat there in the.
Yes, ma'am, clear.
Thank you.
Clear.
Yeah. Now coming to why is scientific inquiry important? Okay, can somebody tell me why it is important? Why do you think we teachers have to shift from experiment to investigation, traditional classroom to inquiry-based classrooms, traditional teaching to an inquiry-based teaching? Why do you think it's important?
I think it is to develop the, lifelong understanding and learning, because once we give them, as you said, the recipe type experiments, they are still, rote learning it. They are memorizing it. But when they do it in this format, which is inquiry based learning, they have lifelong learning and lifelong memorization also. Plus,
Absolutely.
it connects it to, I think, day-to-day life also. When they do it, they are performing it. So it is connecting science to real life scenarios, both the things.
Context. Yes, absolutely. Absolutely, Manisha. Thank you. So, why it is important? It is important because it engages their curiosity. Like I mentioned, everybody is curious. Every human being is curious, right? Every animal is curious. If you see, they want to dig and know what is there, right? It promotes critical thinking. When they collect data, when they are, analyzing things, analyzing their data, coming up with their theories and, relating and researching, they are actually developing their critical thinking skill. They're getting creative by selecting a factor, varying the factors, selecting their variables, right? Writing down, planning the procedures. So all this is going to actually put them into a thinking zone, put them into a problem solving zone. These are all skills that are developed teachers. And scientific literacy, as they do all these things, believe me, they are actually getting, becoming scientifically literate. It's not just for the sake of studying science, I'm doing it, right? So you have to get literate. That's the difference between literate and illiterate. can read and write, cannot read and write, right? So this is what it is. Scientifically getting literate is developed through scientific inquiry. And like Manisha said, bringing life to learning. This is real scientific context. They'll be able to connect with or mirror the real scientific method used by scientists. They'll understand this is what is happening in the research labs. This is what people are doing it in the experimental labs and coming up with the solutions. So my common example with my students always in the science classes is COVID. What has happened, how the vaccine was developed, because they can connect it. So take real context to your classroom, real life examples to your classroom, and you'll see amazing discussions. Recently, 2 days back, was teaching my students about microscope, cells, and bones, bone marrow. In this discussion, I shared my own experience with them. And the experience was how I suffered with a particular rare disease in my childhood and how I came out of it. And you won't believe, by the end of the sharing, they were literally clapping, and they felt, ma'am, we are so happy to see you here today, and now we can understand how microscope is used and what happens in our cells. And teachers, believe me, take these experiences to your class, discuss with them, talk to them, and they will do a great job. They'll start loving your subject, and they'll actually show interest, and they will get curious in what we are doing. Right. So how to do it, where to use this inquiry base? Across all units you can use it, and when you can use it, when you have a phenomena, right? So if you look at all these units, all these subjects, be it biology, chemistry, environmental sciences, mathematics, physics, computers, any of the sciences you see, you will find a phenomena that can be observed in the surrounding, that can be questioned, and that can be explained. So these subjects are actually, we are lucky, actually inquiry-based teaching can be done using this context. How do we use this scientific inquiry? Now, this is what I wanted to introduce today. There's a 5-step inquiry procedure. This is one of it, teachers. There are many more inquiry models. Today, I'm only going to touch upon this thing because this is how you can do as an investigation, because these subjects are your practical subjects. So as an investigation, you can do it this way. So if you have a phenomena, students can develop questions. They'll start wondering what by asking questions or writing down questions. Then they construct some explanation. They'll start thinking. And then they'll plan how to investigate that. And finally, they will come up with arguments and come up with evidence-based, conclusions. So this is a 5-step procedure which you can take to your classroom. Use it. I can pass it on this handout to you. I'll leave my mail ID with you all. You can connect with me. I can give you these steps, and amazingly, you can carry it on to your classrooms. Let's go to the first one. Find a phenomenon. What is happening? Now, these are all the things, like I mentioned. Why are the leaves of my money plant wilting, turning yellow, drooping, falling off? These are very common things they observe, right? Why this is the season for us to experience monsoons, rains, but it's not raining and it is sunny out there. Okay, I'm talking about over a longer period of time or duration. So why? Such are the questions students will observe and come up with. So if you have a phenomenon, find out a phenomenon. In your particular lesson, whatever you're planning now, check for the phenomena. What do you want to teach? And you can find that out. Observe those events which are connecting to their real life context. And then develop good questioning skills in the students. Brainstorm those questions. teach them the ways they can actually develop this question skill. So one is, there are many methods of doing it. QFT method, then there is a questioning frame, where you have levels of questions. You can give that frame to the students and ask them to pick the sentence starters and create the questions. So good questions are what? Which addresses the phenomena, identify the natures of the phenomena. Now, this is a checklist for you teachers to, when you're framing some questions, to bring it to the class, which will provoke, students' curiosity. It's like a provocation activity. You're provoking students' curiosity. How should your questions look like? This is a checklist. Okay. What do you notice? You can frame questions on observational skills, then explanatory skills. How does it work? Okay, what happens in the system? System is something, a big idea. Connect always your phenomena to a big idea, like systems, like change, like relationship, interaction, interconnectedness, right? So these are some of the big ideas you can connect whatever you're teaching your students. Then come up with what is the problem. You can start your activity with a problem. You can show them the problem and then drive them back to actually the phenomenon. So it's beautiful. I mean, you can work it out and it's a doable procedure, right? Step 3, you can, what do you think? Constructing explanation. You can, I'm so sorry. Step 3. Yeah. Yes. You can actually ask students, what do they think? And to build this, construct the explanations in students, build this particular skill in them, thinking skill, developing those critical thinking and creative thinking skills in them. This is a checklist for you. Identify a scientific cause, right? You must be knowing cause and effect model. So use that in this case. Identify a scientific cause. Identify what are the different components pertaining to that particular system or a phenomena. Then use connections between all these connecting ideas, and then you explain, then you describe, then you reflect on what is happening, or you argue on your um, derivations from what you have taken or collected the data. So all these components are there. Computational thinking, of course, that's another big thing. We'll just move forward. And finally, you have step 5. How do you know? How do you know? How do you develop this? This is a claim reasoning with evidence. So you are engaging students in argument. Whatever data they have collected, they have their, scientific arguments based on those data, based on the data they have collected. So a good argument, develop this skill. How it should be? Identify patterns, give them a, prior checklist that, based on these, create what's your claim? What are your points that you need to argue here, or what you want to state? And it makes them, engaging. It makes your class really engaging. Then this is how it happens. Show them the real context. This is how it happens in life. These researchers, scientists, how do they bring these great innovations to life, great innovations to the audience, to the public? Is this format. These 5 steps, teachers, if you take it to your classroom, I'm very sure that your students are going to understand the value for learning what they are learning, and they're going to actually connect their surrounding observations to what they are, and they'll actually know the meaning, why, the impact of your teaching in their life, and why they should be learning is very important. In today's world, the teachers are forgetting to show why. We're just trying to complete our portion and do away with the concepts and practice papers, past papers. This is what the pattern is, right? This is what is happening in the tuition classes, in the coaching classes. But let's make our teaching more impactful to our students, so that It remains in them and it goes with them. So here I'm going to produce a small caselet. Okay, the caselet is the mystery of the wilting plant. So in a middle school science class, Miss Anika notices several students observing a class plant that's been wilting over the past, despite being watered regularly. Now, if you could use these 5 steps and help me know how you're going to use this particular observation of the student and create your lesson based on these 5 steps. Anyone would like to go? Yeah. The first step, I'll help you out. The first step is asking questions. So what should a teacher do?
The teacher can just ask that, what do you notice right now? What is your observation? And
Absolutely.
then maybe the students will come up that some of the leaves or some of the plant is wilting away. So the first step would be just asking, what is your observation?
Yes. What do you wonder? Correct? Remember the second step? We have identified the phenomena, right? We have identified the phenomena, and the phenomena is wilting. Okay? Wilting. So what do teacher do? The first thing she has to do is to create a simple prompt, a simple question. What do you wonder about this wilting plant? And then help students to generate questions like, is it getting enough sunlight? Could the soil be bad, or is it being overwatered? So the teacher has to organize the questions into something which is testable and some which are non-testable ones. So then it drives the students to conduct their planning, conduct their investigation later. So this is how the teacher can start with questioning. Then step 2, developing models. So here the teacher can place the students into groups. Students can draw models to explain what they think might be happening in this scenario. So one group may suggest too much of water caused root rot, and now the plant can't absorb nutrients, therefore it is wilting. Another group may come up with, there's no enough light, therefore it is wilting. These are developing models. Group 1 has come up with one particular idea and the other group has come up with another model. Right. Then carrying out investigations, your next step. So here the teacher sets up 3 identical plants. Okay. Similar conditions given, similar plant. One plant overwatering, another plant poor sunlight, another one with normal conditions. Are you getting me how an experiment is converted to an investigation? So 3 plants giving different conditions. So here now the students will take data. They will start collecting data. They will measure the height of the plant in all 3. They will measure the leaf color in plant. Okay, they can do anything. They can measure the soil moisture, the text, is it changing? Okay, how much of water is there or not? And then the next step, analyzing data. So over a period of 10 days or 15 days, students, they create a chart. They'll put the data there. They'll notice by measuring, the overwatered plant has rotten there, the roots are rotten. Then because there's no sunlight, plant leaves have turned yellow. Then the normal plant is thriving very well. It thrives. Okay. Such is the data. They're just connecting. It could be numerical, quantitative, or it could be qualitative, which is an anecdotal. Like they can write, I can see there is one yellow leaf appeared after 10 days, something like that. They can write. Finally, we have constructing evidence-based arguments. Now, evidence-based argument, you can use here the CER frame. CER, I just showed you in the picture there. It's a claim, evidence, and reasoning. So the claim here, for this particular scenario is overwatering causes root rotting, right, in the original plant. Then evidence is the plant with too much water. The 3 plants what the teacher has conducted this investigation there. So there it is, the plant with too much of water, it showed the same symptoms. And reasoning, the roots can't function properly when waterlogged, therefore leading to nutrient deficiency in plant, and therefore the plant cannot grow very well. So these are the arguments which were backed by sufficient evidence and data. So this is how a scientific inquiry we can say inquiry in action, scientific inquiry in the classroom could look like. So we must know that inquiry is not a fixed lab protocol. It's a scientific inquiry. It's a process, and it is focused on that process, and it is student driven. You're actually making students, putting them in that thinking zone, thinking mode, and asking them to do things. So it's a student driven process. And this particular 5-step model makes it easy to implement it in the classroom. And what you should know is that the phenomena you identify for your particular topics will drive curiosity. And phenomena has to be aligned with your standards, and they are aligned. Whatever you're teaching, like we have textbooks, content, subtopics, right? Pick one. That's how we plan our lesson plans and units. So we just pick one particular concept. Show them that this is the connection for your real life context. Show them in what is happening in their context. Go from problem to the investigation. And that will create argumentation, and evidence are at the heart of science. Science-based unit, science-based inquiry, you have arguments which are backed by evidence, right? And inquiry builds conceptual understanding. So as I mentioned, identify the concepts. Concepts which are scientific, which are your subject-specific concepts, okay? And which are your big ideas, key concepts. Like I just mentioned, connected to system, okay? Like photosynthesis, it's a process. It's a process of changing. So change could be a big concept, big idea. So you can see concept is something which student can take it to any different scenario and connect it. For example, if I'm saying photosynthesis as a science teacher, I have taught about photosynthesis process. So photosynthesis process is a concept. I'm connecting this photosynthesis phenomena to a particular concept which is called change. So what is changing here? The nutrients like carbon dioxide and water are converting to glucose, right? So how are they changing? And this change, they can take it to their other, other subjects. They can connect it. Change. What is changing to what? Why there is this change? System. For example, you want to connect photosynthesis to system. There's a proper system in autotrophs which can conduct photosynthesis process, which is not there in heterotrophs, which is not there in us, right? A system, then they will take it to their social studies classroom. Now, government system, how does it function? Without these particular components, they are all dependent on each other, and that's how governance is seen in a country. That's how a government functions, right? So connect them to bigger ideas. So it's a conceptual understanding. That's another topic, and I'll be taking a session on this in future sessions are planned on conceptual understanding. And if we as science teachers, if we as teachers understand that we are not going to a classroom to teach only the content, but to develop the context, to develop the concepts using a context, that would make our students' life easier and their learning impactful, their teaching impactful, their learning actually meaningful for them. So this is what we should be knowing, that it's quite easy to perform it. Then there are certain theories and teaching strategies that are connected. If your classroom is an inquiry-based classroom, scientific inquiry is seen in your classroom, it's the constructivism theory, right? Building on concepts. Then inquiry-based, asking, putting the students into a zone of thinking and posing questions, framing their own questions. Visible thinking. Visible thinking is making thinking visible. Not that students are thinking and we teachers don't know what they're thinking, right? So we know, make it thinking. CER, I told you, claim, evidence, and reasoning. Give them the format. Let them write there. What they're thinking, let them put it there. So that's visible thinking. Bloom's taxonomy, as I mentioned, that take them from understanding level to a creative level. Make your plans from, understanding level and raise them, modify them to a creative level using this technique. Socratic method, we all know. Put them into a zone of arguments, put them into a zone of bringing their discussions onto the table. Let them come, let them debate, let them talk, let them speak out, right? So when they talk aloud, when they think aloud, they'll talk aloud. And when they talk aloud, your classes will be actually meaningful, right? So here I will end what I had to show it to you and bring to you. I would like you to reflect on how the session went off, and what you have learned. Key takeaways from your session today. Yeah, anyone?
Ma'am, I would just like to, conclude that till now, probably even I was under the misconception that inquiry-based learning is about just asking questions. But it is not just asking, it is just the starting of the process. And as you said again and again, it is the process. It cannot be done in a single class. It will take time and probably few um, days and weeks to complete the entire process and experiment that we want to do. So I think this is one clarity that has even come to me today, and thank you for it. Thank you so much.
I would like to tell you all that, it doesn't have to be, you don't have to follow these steps in this order. All right. You can just, first take the first step, asking a question. You have identified your phenomena, take the questions. Ask students to come up with their questions. They can then plan an investigation, or they can then research, and then they can go back, like I mentioned, give them a problem, take them back to your phenomena, or pick an innovation and drive your unit, or show them the, actually the context and take them back. So it is really going to be, make their learning an impactful learning. Yes. Thank you so much for this opportunity, and thank you for joining in, all of you all. Thank you, Ravi sir. And I would like to um, I'll leave my mail ID with sir, and if anyone would like to connect with me, you can do so. I'll be more than happy to connect and share my learnings as much I know with you all. I can help you out in planning also. Thank you so much.
So thank you so much, Vichitra ma'am. Indeed, that was a wonderful session. And I believe there are many aspects which you have covered, which most of us didn't know. Maybe few people are knowing, but the process through which you have taken each one of us would definitely help us to stick on to the exact and authentic process of inquiry-based learning. So indeed, we are very much what do we say, happy with that, and lots of appreciations from the end of what do we say, SNTTC to you. And thank you, dear participants. Looking forward to have you all in the upcoming sessions as well.